Hello, my name is Tatiana Kurzner, and I'll be your SQL instructor for today. Let's look at what is SQL. SQL is a structured query language. Um, it's a tool for organizing, managing, and retrieving data stored by a computer database. What is relational database? It's also called RDBMS. It's a collection of organized data. And R stands for relational because sometimes they call it RBMS or RDBMS. So that's the difference. The word is relational is the difference. What is the table? Let's look at how the table looks. This is the table course. And it has two columns. One is a course ID, one is a course name. What we see vertically is columns. What we see horizontally is records or rows. So this particular table has 2 columns and 4 rows. What is a primary key? Primary key is not null and it's unique. Every relational database has a table with a primary key. Why is this important? It's important because in order to keep the integrity of the database, all the tables need to be related to each other and all the tables should have a primary key. Primary key should be unique. Like in this table, for example, course ID is unique. If we look at another table, student, we can see that student ID is also unique. However, course ID is not unique anymore because we see 2 people, Jim and Amanda, who have the same course ID. They both take class called computing, and it's normal because course ID is unique in a course table, but not unique in a student table. Therefore, course ID is primary key in a course table, and student ID is primary key in a student table, and course ID in student table is a foreign key. Foreign key is important because it's going to be connected to this course IDs will be connected together in order for us to run a SQL statement. Let's look at what is SQL, a really SQL code or a query. There are 4 categories in SQL code. They are select, from, where, order by. A little more details on that. What do we select? Our job is to get information from a table or a set of tables. Therefore, we need to write the code to get that information. For example, we need to get Jim out of this table, right? We need to get this person, this record. How do we do that? We need to write the SQL code. And how do we write this? There is a code. There's 4 main categories: select, from, where, order by. What is a select star? Star represents every single column in that table. We can write select student ID, comma, first name, comma, last name, comma, course ID. That way we can spell out all 4 columns. But instead we can just write select star, which will be a selection of all 4 columns. We don't have to select all 4 columns. We can just select first name or select last name. It doesn't matter. After select, we just list columns that we want to see in our output. From a table, it's always a table name after from. Where, so here's the actual query. What are we actually selecting? We're selecting a specific column, for example, first name, where first name equals Jim. So that's how we can get Jim's record, the whole record for Jim. So that's how the typical SQL code looks like. Let's look at the specific example. For example, we have a table, course, same table, and we need to show course ID for history. So we can find history here. The course name is history, and we need to show course ID. So the question is asking us to pull this P301, and we need, how do we get this information out? We need to write a SQL statement where we select course ID, course name from table course, here's a table, course, where course name equals history. So this is the query, SQL query for this question. So whenever you have a question, always try to think what exactly do they want from you, because understanding the question is half of the solution. So what will we see in the output? This is what we'll see in the output. We'll see our course ID P301 and course name history. Let's look at another example with another table. And the table is student, and the question is, show all records for Simon. The last record in this table is for Simon, so they want us to show all 4 columns, right? They want to show student ID, first name, last name, course ID for Simon. So this is the last row that needs to be in the output. How do we do that? We do select star. Remember, star represents every single column in the table. From student, here's our student table, where first name equals Simon. So the output will have just one record for Simon. So this is an easy SQL query, just you know, with a simple where clause. Now we need to look at the joins, because if we want to connect 2 tables together, we need to understand the joins. And here's the all the joins that exist in the SQL database, in the relational database. Inner join is when you join 2 tables, and only the records that are the same will be shown in the output. The next join is left join. Same tables, but all the records from table 1 and only the matching tables from table 2 will be presented in the output. Right join is just the opposite of left join, and full outer join is when you join 2 tables together and you want to see every record in the output. From the for the purpose of this lesson and what happens in the reality, I have to tell you that nobody uses this in the real life. Nobody uses right join because it's confusing, and the full outer join is just not used much in the business at all. I never use them at my job, so I really want you to understand that these joins exist for the purpose of you answering questions at the interview, but nobody will ever ask you to do any kind of work on these 2, joins on the right. You will only be asked to do joins on the left, inner and left joins. So these 2 joins will be focused on, and you need to understand these 2 joins, inner and left. So let's look at the another scenario of finally joining student and course tables together. You probably remember that this course ID is where the relationship is. Course ID is a primary key in course table and foreign key in the student table. So now that we know how these two tables are joined, how we're gonna see it in the SQL. So let's look at the SQL. And the question is, show all students and their courses. In order for us to answer this question, we need to join two tables together, and we're joining them on the course ID because that's our joining column. So we do the same. We do select star, means select all the fields from student table. And now there is a new word for us, join course. So that's another table. On, and then we'll list the table name, column name, equals table name, column name. So basically, we just join these two columns from two different tables together. How is the outcome going to look like? Here's how it's going to look like. We're going to show all the students from one table and the course name from, and course ID again, and course name from another table. We'll basically just get every single field, right? There are 1, 2, 3, 4, 5, 6 fields. We get all of them. So fields and columns are the same thing. So we get 6 columns or fields from both tables in our output. Next. Which course does Amanda take? We want to see the course name for Amanda, and therefore we need to join these two tables again. We already know how to join them. We join them on course ID. But this time around, we actually create aliases for both tables. Why do we need aliases? Because SQL codes can be really, really long. Tables can be called very long names. And nobody wants to drag along the, those names. So we can just call the student table A and course table B. Alias, it exists only in our SQL code. It doesn't record anything. It's not stored anywhere. It's just for the purpose of convenience writing the code. And clarity, when you look at the code, you understand it better. If you call A and B and you join on A and B, it's easier to read, and a lot of people use just A, B, C, D, naming the tables, because this is much easier for people. So we call student table A, course table B, and we join this field A and B together, where A first name equals Amanda. So the output will be first name Amanda, course name computing. Computing from this table, Amanda from this table. So what is the left join? Let's look at the left join. What's going to happen if we do the left, instead of the word join, which represents inner join, we'll write left join. If we write left join, we actually telling the database, so show every single record for course and only records that match from student. So that's how you read it. You show every single record from course and only records that are similar from student, that are matching from student. So this is how it's going to look like. And as you can see, not every record is the same, right? For example, there is no student for course for history. Nobody is taking history course in our table, in our student table. Therefore, we're showing every single course that exists in the course table, and only records that are matching from student table, and nobody's taking history, so this will be blank, nothing. So this is the left join, all the records from course and only matching records for student. So let's look at the group by. What is a group by? It's a very important part of SQL. And I got this, it's another database. I got it from Data School, so you can look at this yourself. But basically, group by we can show on the example of Facebook table. Look at this table. It has 4 names: Matt, Lisa, Jeff, and Sarah. They all have certain number of friends. If we want to know how many names are there in the Facebook table, we need to write the query select count star from Facebook. What it does, it just counts every record that is in the table. And there are 4 records, so the return is, the output is 4. There are 4 records in the table. If we want to see the same thing only in our Facebook table, we have a new column called state. So we now list the state for each name. And we see that there are 3 people from California and 1 from Florida. We want to count how many people live in each, how many people from each state are in Facebook table. So obviously, in California, there will be 3 people, in Florida will be 1. But how do we write the code? And we write the code this way. We select state and count star. So now we added the word state in here. See the column state. From Facebook, group by state. Now we need to group by state in order to see this, the count from each state. This is called group by. When we didn't have state, we just wrote select count star from Facebook. But now we added a state, and that's why we need to write group by state. That's how SQL understands the aggregations. So group by is an aggregation. Let's look at another scenario, which is a little bit even more complicated. If we added a city for each of the people on Facebook. So in California, we have San Francisco, Los Angeles. So here's the code. Same thing, we just added select state, city, and then count. Now in our group by, we need to put state and city. And the final output is gonna look like this. From California, there is city, San Francisco, there are 2 people. In California, city, LA, there's 1 person. In Florida, city, Miami, there should be 1, not 0. It's a mistake here. So this is what we call group by. And if we want to know how many friends are there all together, we'll just write select sum of all friends. And we see there are 1,800 friends in this table. You can sum them up and see there's 1,800. We can also calculate the average by state, average number of friends by each state. And this is another group by that we wrote. And you will see that in California, there is an average of 466.67 and 400 for Florida. It doesn't change because it's only 1 record, right? But if you do the average for these 3 numbers, it's going to be 466.47. So let's look at the database number 3 to see just some more scenarios of group by, and joining tables together, you will see, you see two tables, school and student. So how are they related? They are related by ID. School ID is here and school ID is here, right? There is the relationship in blue. And the question we have is, which is the date of, what is the date of birth of the youngest student at each school? So in order for us to find the date of birth of the youngest student, we need to put the max date of birth. This is going to be the youngest person, right? And we need the student, right? We need the student name. So here's the name of the student. So basically we need this information, name and date of birth, right? But, oh, we need the youngest student by school. So we need the date of birth from this table and the name of school from this table, right? So we need name from here and date of birth from here. How do we do that? We need to join them on school ID. And this is how we do it from school A, student B, on AID equals BID. This is how we join the tables. Now that we know how to join them, let's get the information out of these tables. So we need the name of the school, and that's why I write A name. So a name. So this is the name of the school. And then max of birth from this table. And we group by name because we already know that whenever we have an aggregation of some sort, we need to write group by. This is how this SQL works. So what's our output? Here's our output. It's the name. So each school has the youngest, person. Okay. Same tables, but another question. The question is, how many students go to University of Applied Science? So here's the University of Applied Science, school number S002, which is like 2 students right here. And the question is, how many students go to, right? So there are functions that we can use. We can use sum, average, min, max, count. In this case, we do the count. Why do we do the count? Is because that's, if we want to count the number of records, we always do the count. And we call this, we do count star, count all the records, and we call this field, where this, we call this number of students. Why do we call it number of students? Because we want to see the nice output so that it's pretty when you see the results back. If you don't rename it, number of students is just going to be count star. But we want to see something nice, so we name it number of students. So again, we join the two tables together on school ID, and we just write where name equals, name of school equals University of Applied Science. So how many students go to University of Applied Science? Linda and Jonathan. So there are 2 students. And do you see this nice number of students in the output? It's not count star, it's number of students in the output because we renamed count star. We gave a different name. It's all done for the output so that, it's more meaningful way to see the results. So what is SQL? SQL has 3 different languages in it. It has a data query language, which is DQL, and everything I showed you so far was a DQL. It was a select statement. And select statement works, select columns. So we do manipulate, we manipulate with columns, we show columns. And data manipulation language, DML, it's another part of SQL, which is usually not asked at the interview, but I still want to show you what it is. It's whenever you insert, update, and delete records. I'll give you some examples. Nobody will probably ask you to do this at the interview, but I want you to know that that exists. If you want to manipulate records, you need to know DML. There's also data definition language, which is any kind of manipulation of the tables that has anything to do with tables. Create table, alter table, drop table. Let's look at a little example on the school table. So this is a school table. What is a DML? DML is data manipulation language. That's how we change the records. If we want to add values, we want to add one more school, University of San Francisco. We want to add record number 3 to this table. This is what we need to do. We need to write this statement. Insert into school, list the column names we need to insert it into, and then we write the word values, and we put the values that we want to add to this table. This is how we insert the table, the records. If we want to update this table and change the University of San Francisco that we just added, we want to rename it to University of San Fran, right? We need to write an update statement. Update school, set name equals University of San Fran, where name equals University of San Francisco. If we want to delete the record we just created, we need to write delete from school, where name equals University of San Fran. So this was DML. Now DDL. What is a DDL? DDL is, we use DDL every time we create a table. And this is how we would create the table school. We create table school, we write the column ID. We defined it as a varchar 4, not null. And second column is name, varchar 50. And we say that primary key is an ID. This is DDL. This is when we create a table. It's called data definition language. Now, if we want to alter this table, we'll write alter table school, rename column name to school name, add column, school address. That's when we want to add a column to this table. And when we want to get rid of this school table, we just write drop table school. That's it. So this was just a little example of 3 languages that are inside SQL. Here they are again. Is DQL, DML, and DDL all together. They're called SQL. Okay. Database number 4. There are 3 tables in the database number 4, customers, orders, and items. Customers and orders are related by customer ID. Customer ID here, customer ID there. Orders and items are related by order ID. Order ID here, order ID here. So customer ID here is a primary key, customer ID here is a foreign key. Order ID is primary key in orders table and foreign key in items table. So if we want to do 3 tables inner join, we just write select star from customers, join orders. And notice I gave aliases here, but I didn't do A and B. I just did the alias of the first letter of the table name. So people do that also. They either call it ABC or they call it by the first letter of the table name. So customer becomes C, orders becomes O, and C.customer ID equals O.customer ID. So what do you think we will see in our inner join? There is only one customer ID 1 that exists in the order table, right? There's no customer number 2 here in this column, see? That's why we will not see customer number 2 in our output. We will only see, this is an inner join, remember? So only records that are matching. Therefore, we'll see customer number 1. And customer number 1 just happened to be mentioned 2 times here in the orders table. Therefore, we will see 2 records in our output because there are 2 records in the orders table. So we show everything that matched. So we put customer ID 11, same thing, same thing, same thing. And when we see order ID from this second table, that's when we write order ID 4, order ID 6. So that was inner join. Okay, same database, but we want to show left join. We do the same thing, but we do left join. What will we see if we do left join? We will have to see customer number 2 because we're joining every single record from customer table and only matching table records on orders. So table, what are we going to see? We're going to see this. Now we see the customer number 1 and we see that there is blanks for the orders, anything that's related to orders table. Next question. We join 3 tables together and this is how the join looks like. Customers, orders, items. We called item table alias as I because we already started this trend, right? But you know, customers is C, orders is O, items is I. This is how we join 3 tables together. And here's our output. Now we see 3 records. Why do we see 3 records? It's because obviously customer number 1 exists in this table. We would see 2 records. We used to see 2 records before, but why do we see 3 records now? It's because items table has 3 for order number 4. It has it doesn't have order number 1 here, but it has order number 4, order ID 4, 3 times. That's why we see 3 times the records. I hope this is clear. And the last is interview and questions, and there are many of them on the internet. We'll just look at a few, but you're welcome to look at the questions and answers. So let's look at the interview questions. What is a database? Database is an organized collection of data stored digitally, obviously. What is DBMS? DBMS is a data management system. RDBMS, it's a relational database management system. What is SQL? SQL is structured query language. What is the difference between SQL and MySQL? Well, MySQL is a database. SQL is a language. So it's a language and a database. It's 2 different things. I never heard this question, but okay. What are tables and fields? Fields is same as columns, actually. So tables is a organized collection of data where in the form of rows and columns. So columns are vertical and rows are horizontal. Next question. What are the constraints of SQL? Well, out of all this list, what's important is that not null, obviously primary key is not null and unique. It's a unique record in each table. Foreign key is same key only in another table, and it's important for referential integrity. Because if you screw up the primary foreign key relationship, it's not going to be a relational database anymore. And it's important to keep the relational database and keep the referential integrity in place. Index is important. DBAs do indexes for faster retrieval records. So they put indexes on tables where it's appropriate. What is a primary key? It's a constraint, as we just saw before. It identifies each row in a table. It must be unique. It must be not null, and so forth. We already looked at it. This is just a create table statement, and primary key, it's usually used at the end like this in this fashion. You can always, you don't have to put primary key when you create a table. You can always add primary key later. It's just a statement how to add it. Not null, unique, not null. Unique is a constraint that ensures that all values are in the column are different. So primary key should be not null and should be unique. This is the definition of a primary key, basically. But you can always put not null on any field in your, on any column in your table. It's, for example, if you write records of people, each of them should have like date of birth, for example, or first name and last name. First name, people should always have first name in your customer table. Otherwise, you don't know who this is. I mean, it's a, I would put not null for first name always. So what is a foreign key? It's actually a primary key in another table that you join to. So just you can put primary key and foreign key on the same table. What else? I mean, joins we just looked at. So it's a inner join and left join are two most important joins. Everything else is irrelevant in the business world. You can say that. Just some examples of inner joins and left joins. Right joins, I wouldn't even look at right joins because they're so confusing and they're not needed. Just be brave and tell the person at the interview that I don't want to talk about right joins. They're not used anywhere. So why talk about that? And full joins used very rarely for very specific things, and people are afraid to use them because think about it, you need to join all tables together and get all the records. And if there are millions of rows, you can bring the database down if you join all of this together. So people don't like doing that and don't want to talk about it. But it exists in the language, in the SQL language. You can do that. You can do full outer join. What is a self-join? Self-join is when you join two tables together, same table together 2 times. So it's employee, you join to employee, self-join. Why do we do that? It's usually used to show a supervisor. There is one employee table and you want to see who reports to who. And that's basically the only way I know, the only example that everybody uses and it's ever used, self-join, is for this, to look at the employee supervisor. Cross-join, nobody ever uses cross-join, so I don't think you need that. Index, it's a, it's a constraint. So people create indexes in order for tables to in order for SQL code run faster. Yes, could be unique and not unique. I mean, they're more like DBA, database administrator type of questions. They are not really, I don't know if anybody would ask you these questions. So what is a query? Query, it's a request for data or information from database or table. So so queries can be really a select or action. Yes, because if you just select, you don't do any harm, you select. But when you action, this is action query. When you update, that's when you can really do damage. So make sure you know what you're doing when you updating tables or deleting tables. So subquery is a query within a query, but that's more like deep SQL if you want to go that way. I don't know if anybody will ask you for it's not an easy SQL anymore. It becomes more intense. So this is it. I think I hope it was helpful. And again, my name is Tatiana Kurzner, and this was an SQL lesson. I hope it helps. And let me know if you have any questions. Bye.